So hello students. So today discussion is about the modern approach to the chemical bonding. So what is chemical bonding, students? Hello students. Today discussion is about the modern approach of the covalent bonding. So what is covalent bonding, students? Covalent bonding means the bond formed by sharing the electrons is called as covalent bonding. So how do they share the electrons? In general, atoms, how do they share the electrons? Like practically, if you want to represent, we are representing by circles, yes or no. But atomic level, how these atoms they share electrons, students, that will be explained by a theory called as valency bond theory. That means valency bond theory explains how do atoms share electrons. For example, in the case of ionic bonding, we can simply say an atom loses electrons and another atom gains electrons, right? They can form the ions, positive ions and negative ions. But when it comes to the covalent bonding, how can they share electrons, students? How do they share the electrons? The covalent bonding, sharing electrons will be clearly explained at that atomic level by the VBT, valency bond theory, proposed by the scientists Hitler and London and later extended by the Pauling and Slater. So in this theory, according to this theory, students, in general, atoms during bonding, the orbitals will overlap with each other. During sharing, what happens? The orbitals will overlap with each other. This is the main point of this valency bond theory. The covalent bond is formed by the overlapping of atomic orbitals of valency shell of the two atoms. So atomic orbitals means how many orbitals are there, how many shapes electrons are revolving. Electrons are revolving in the spherical shape, electrons are revolving in the dumbbell shape, double dumbbell shape and complex shape, S, P, D, F for the orbital. So the concept of chemical bonding is applied for S block elements and P block elements. That's the concept we have. So let us consider S orbitals and P orbitals overlapping. So students, how do they overlap? Which orbitals do they overlap? Do all the orbitals overlap? No, only the valency orbitals, valency shell orbitals only overlap. That means, do all the electrons present in the valency shell orbitals again? No. Look at the second point. Only half-filled atomic orbitals, that is orbitals singly occupied, can enter into the overlapping process. This results bond acquires a pair of electrons with the opposite spins. That means one revolves in clockwise spin and other in anti-clockwise spin. They overlap with each other. Which orbitals? Half-filled orbitals overlap with each other. The atoms with half-filled orbitals must come closer to one another with axis in the proper of direction and overlapping. So ultimately, according to VBT, sharing of electrons means at the atomic level, what is happening, students? The orbitals of these atoms overlap with each other. Right, greater the overlapping, higher is the strength of the chemical bond. If more is the overlapping, that means if these orbitals completely merge, completely overlap with each other, the bond strength will be more and the molecules, the combining elements, they release high energy, that is called as bond energy. That means, if it is a strong bond, is it easy to break that bond? No, the bond energies will be higher. So when the extent of overlapping will be greater, then they release high energy, students, and the bond strength will be very, very high. So, and stable than the isolated atoms. And that ultimately why these atoms are combining to form a stable molecule. So, valence electrons and the valence of bonding atoms. Electrons which are already paired in the valency shell can enter into the bond formation if they can be unpaired first and shifted to the vacant orbitals. What's the meaning of this point? And these state of these electrons are called as excited state. I'll explain about this point. Listen, students. Look at this example. Look at the boron configuration. Students, what is boron's electronic configuration? 2s to 2p1. Yes or no? Boron's electronic configuration is 2s to 2p1. 2s is completely filled. You can see one is clockwise spin and another one is anti-clockwise spin. 2p contains one electron, right, students? Now, what happens? There is only one half-filled orbital. That means, does it mean only one orbital involved in the bonding? No. No. Why? Because the completely filled orbital, the electrons from the completely filled orbital excites to the empty orbital, and now look at the number of half-filled orbitals. The number of half-filled orbitals will become 3. Now, boron valency is not 1. Boron valency becomes 3, students. Why? More is the bonding, more is the stability, more is the release of energy. That means if there is a chance for excitation, electrons from the completely filled orbitals, they will excite to the vacant orbital. So wherever there is a space, whenever there is an energy, they will excite and they try to form maximum bond. So this previous configuration is called as ground state configuration, and now this configuration is called as excited state configuration. Students, got the clarity? This is boron's excited state configuration. So what is this configuration? Previous it is 2s2 2p1, now it is 2s1 2p2, right? Now these 3 electrons involved in the bonding. These 3 electrons undergo sharing. That means these 3 orbitals undergo overlapping. Next, look at carbon's configuration. Carbon's general configuration is 2s2 2p2. Yes or no? So one is completely filled 2s and 2 are half filled orbitals. That means the valency, what is the valency of carbon? Is it 2? No, the valency of carbon is 4. How it is 4? The completely filled orbital of the electrons excites to the empty orbital. There is one empty orbital or not? And now look at the half filled orbitals. The number of half filled orbitals becomes 4. Now all the 4 orbitals involved in the bonding. That's why carbon will get a stable octet configuration, students. Now what is the valence of carbon? The valence of carbon is 4. Now this configuration is called as excited state configuration. That's what the previous point is saying. So elements from their ground state can excite to the vacant orbitals to become excited state configurations, and then the chemical bond formations takes place. For example, look at we have one more example, which is with phosphorus. Phosphorus electronic configuration is 3s2 3p3. 3s2 3p3. So how many half filled orbitals are there? There are 3 half filled orbitals are there, students. And look at 3s, it is completely filled or not? And now how many electrons are there here? How many electrons are there with half filled configurations? Only 3 electrons are there. And that means, does it mean the valence of phosphorus is 3, right? The valence of phosphorus is 3, but the completely filled orbital of 3s excites to the 3d empty orbital, excites to the 3d empty orbital. Now how many half filled orbitals are there? You can count 1 2 3 4 5. Now the number of half filled orbitals will become, students, 5. What is the new valency? The new valency is 5. That's why phosphorus can form phosphorus trichloride PCl3 as well as phosphorus pentachloride, which is PCl5 also, students, right? So next, based on the difference in the overlaps, covalent bonds are of 2 types, sigma bond and pi bond. I said now all these undergo overlapping. Then what is the overlapping? Like how do they undergo overlapping? Mainly these overlappings are 2 types, students. One is end-to-end overlapping, the other one is sidewise overlapping. End-to-end overlapping as well as sidewise overlapping. If orbitals meet end-to-end, then that is called as sigma bond. If the orbitals meet sidewise, then that is called as pi bond. Simple. So the covalent bonds produced formed between the 2 atoms by the end-to-end overlapping of half filled orbitals only along their axis is called as sigma bond. So where the sigma bond is present, sigma bond is the first bond formed between the bonded atoms. Sigma bond is strong because the extent of overlapping between the 2 electron clouds is maximum. Remember, students, when 2 atoms comes closer, definitely the first bond is sigma. Why? Because, students, answer p subshell. How many orbitals are there? 3 are there. One is along the internuclear axis, one is away from the internuclear axis, one is diagonal cross z axis. Yes or no? X axis orbital, y axis orbital, z axis orbital, and in other atom also same. So when these 2 atoms come closer, which orbitals will meet first? Like x axis orbitals or y axis orbitals? X axis orbitals. So this overlapping is called as sigma. That's why when 2 atoms comes closer, what is the first bond? Definitely sigma bonding only, for sure. The first bond is always sigma bonding, students, and it is very stronger. You know why? Why? Because these sigma bonding orbitals are exactly between the nucleus. So then where are the pi bonding orbitals? Pi bonding orbitals are away from the nucleus. That's why pi bond is a weak bond, sigma bond is a strong bond, and the extent of overlapping for sigma bond is also very high. So look at the types of overlapping. Let's see how sigma and pi bonds formations will take place. So first, so between s and p orbitals, what are the possible combinations we can expect? SS combination, SP combination, as well as P and P combination. Yes sir. First we have S and S overlapping, students. So the best example, hydrogen gas made up of 2 hydrogen atoms. What is the configuration of hydrogen? 1s1. What is the configuration of another hydrogen? Same 1s1 only. Where the valence electrons is present? S orbital. Yes or no? That means the electron present in this S orbital overlaps with the electron present in the another S orbital. Understood? That's how they can form H2 hydrogen gas. So look at the overlapping. What is the shape of S orbital? Spherical. Spherical, students. Spherical shape. And what is the shape of another S orbital? Also spherical. So when they combine, look at now where the electron cloud is present, students. Is it away from the nucleus or exactly between the nucleus? electron cloud is present exactly in between both the nucleus. That's why sigma bond is always strong. And what is this overlapping? This overlapping is called as end-to-end overlapping. Whenever s orbital overlaps with another s orbital, 100% that is sigma bond. This is end-to-end overlapping, and this is the strongest bond. Remember, S and S means definitely sigma bond. Now, S and P overlapping. Let's see. What is the example given here? Hydrogen fluoride. What is hydrogen configuration? 1s1. What is fluorine's configuration? 2s2 2p5. That means where is this half-filled orbital present? In the p subshell or not, students? Now, when this s orbital overlaps with p orbital, look at this overlapping. This is s orbital of hydrogen. This is p orbital of fluorine. When they overlap, this overlapping is also called as sigma bonding. End-to-end overlapping only. You can see the electron clouds are exactly between both the nucleus or not. This is the nucleus of this atom, and this is the nucleus of another fluorine. This is fluorine atom. This is the nucleus of hydrogen atom, and this is the nucleus of fluorine atom. Where these bonding electrons are present? Bonding electrons are exactly present in between both the nucleus. So this bond S and P overlapping is also 100% sigma bond only. This is also called as end-to-end overlapping only, where the p orbital meets s orbital, not meeting, overlapping. So ultimately overlapping means sharing only, sir. No. Third possibility, P and P. So S and S is sigma, S and P also sigma. Then what is P and P? It is also sigma only. Here, students, P and P, there are two possibilities. One is, you already know, like I already have said, P orbitals, how they are present? One is along the internuclear axis, horizontal orbitals, and other are vertical orbitals. Yes or no? When horizontal orbitals, when they meet with each other, this is end-to-end overlapping. You can see this is the orbital, horizontal orbital. Yes or no? This orbital is called as orbital along the internuclear axis. When this meet with this atom, this type of overlapping is called as head-on collisions, head-on overlapping, or this overlapping is called as end-to-end overlapping, and definitely the bond is sigma bond. You can check the electron cloud. Electron cloud is exactly between both the nucleus. Yes or no, students? That's how the sigma bond is always a strong bond. Between any two atoms, what's the first bond? Definitely, which orbitals will meet? These orbitals or these orbitals? These orbitals will only meet first, students. Definitely the bond is sigma. And look at other possibilities of pi bond. What is pi bond? Sidewise overlapping. When we can expect a sidewise overlapping? When the orbitals along the internuclear axis meet with each other, and when they come closer each other. Now here orbitals are there, students. They will meet first. How do they meet? Is it they will turn? No, they will meet like this. This is sidewise overlapping. You can check the image. This is p orbital away from the internuclear axis of one atom, and p orbital of the another atom. They will come. Where is the nucleus? This is the nucleus of one atom. This is the nucleus of the another atom. Look at the electron cloud. Where they are present? Are they present exactly in between the nucleus? No, they are present away from the nucleus, students. That's why pi bond is a weaker bond. Can you imagine where is the sigma bond here? There is no sigma bond here. There is a pi bond. But ultimately sigma bond, pi bond is present between the same molecule, right, students? The sigma bond is present in between the nucleus of these two atoms. The previous, no? In between the nucleus. Where we can expect the pi bond? Pi bond we can expect here. Away from the nucleus, pi bond. Between the nucleus, sigma bond. So this is a separate representation of pi bonding, and this is a separate representation of sigma bond. If you want to combine, where the electron cloud of sigma bond present? In between the nucleus. Where the electron cloud of pi bonding present? Away from the nucleus. So that's how the pi bond formations takes place. So ultimately, students, covalent bonds are three types based on the number of electron pairs shared between the bonded atoms. First, single bond. Single bond. If there is only one bond, that bond is always definitely sigma or pi? Always 100% sigma bond, students. Covalent bond only. In covalent bond, it is always sigma bond only, and it contains a bond is made up of how many electrons? One pair of electrons. If it is a double bond consists of one bond, one sigma bond, and one pi bond. If definitely one is sigma, the first bond is sigma. What is the next bond? Next bond is always pi bond. And how many electrons are there total? 4 pairs of electrons are there. Yes or no? A bond is made up of 2 pairs, students. If it is a triple bond, say first bond is always sigma. Now the next bonds are pi bonds only. Which bonds, students? Once again I am saying p orbital contains 3 orbitals. One is along the internuclear axis. They will always form sigma. Remaining are away from the internuclear axis. They always form pi bond. 2 pi bonds and 1 sigma bond is present in a triple bond. Look at the examples of molecules having multiple bonds. and this is oxygen molecule. Students, see, oxygen configuration is 1s2, 2s2, 2p4. Now, how many half-filled orbitals are there? 2 half-filled orbitals are there in the p subshell. So, this is one, this is one. When these two atoms come closer, which atoms will meet first? Here it is representation px, py, pz for our understanding. Okay, ultimately all are p orbitals only. Which orbitals will meet first, students? Pz orbitals or py orbitals? You can see pz orbitals will meet first. Definitely, what is the overlapping? End to end. That's why the first bond is always sigma. After meeting, then how do they will meet? You know, to meet these orbitals, these two atoms need to become closer, more or not, students? They'll come more and more closer. That means the extent of overlapping is increasing or not. If the extent of overlapping is increasing, the bond strength is increasing or not. That's why sigma bond is more stronger than pi bond. So look at the pi bonding orbitals where they are present. This is the nucleus. This is the nucleus of another atom. This is the sigma bond electron cloud. These are the pi bonding electron clouds. Got the clarity? That's why pi bond is weaker bond, sigma bond is a stronger bond. So last, formation of nitrogen molecule. What is nitrogen configuration? 1s2, 2s2, 2p3. Total how many electrons are present in the valence shell? 3 electrons in the p subshell, right? Px, py, pz. Look at here, students. All the 3 orbitals are present. In the previous example, all the 3 orbitals are not given. Why? Because it is completely filled, not involving in the bonding. That's why. So here all the 3 p orbitals are present. Now these two atoms, when they come closer, like from the beginning I am saying, which orbitals will meet first? Pz orbitals, px orbitals or py orbitals? Pz orbitals will meet first. Yes or no? The orbitals which are along the internuclear axis. When they meet like this, what is that overlapping is called as? Sidewise or end to end overlapping, they can form sigma. After meeting together, they need to come more and more closer. Then this px overlaps, px orbitals overlap another px orbital of another atom. Yes or no? Now py, 2py orbital overlaps with 2py orbital of another atom. Now these 2px, 2py, 2py, do they overlap end to end or sidewise? See, look at the representations. They overlap sidewise. Sir, how do they can, do you think they can bend? No, already sigma bond is formed between. Does it break? No. So they will meet like this. This is sidewise overlapping. So first bond is always sigma. If it's a triple bond, first bond is sigma. Remaining 2 bonds are pi bonds. Remember, between any 2 atoms, the first bond is always sigma, students. So this is valency bond theory. What is valency bond theory? It's a modern approach to the covalent bonding. Covalent bonding takes place by sharing electrons. How the sharing electrons takes place, students? By overlapping of the atomic orbitals. If it is an end-to-end overlapping between S and S, S and P and P also along the internuclear axis, this is sigma bond. If it is sidewise overlapping between py orbitals or px orbitals, then that is pi bond. Between any 2 atoms, what is the first bond? Sigma bond only. Remaining bonds are pi bonds between any 2 atoms. Which is more stronger bond? Sigma or pi? Sigma. Why? Electron cloud is exactly between the nucleus, and the extent of overlapping of sigma bonding orbitals is also more. So this is the valency bond theory. Students, I hope you got the clarity. Thank you, students.